Good morning. I am V. Prasannanjaneya Reddy, working as Assistant Professor in the Department of ECE, Institute of Aeronautical Engineering College, Dundigal, Hyderabad. In this session, we are going to discuss about how we can choose a real-time operating system. First, what is an operating system? Which acts as the bridge between actual hardware and user applications. So, how we can choose which one is suitable for our design? So, a lot of factors we need to consider while choosing the real-time operating system. That factors may be either functional requirements or non-functional requirement. We will check one by one. For this topic, we can refer the textbook is Introduction to Embedded System by Shibu KV. So first, functional requirements. First requirement is processor support. Our operating system is supporting the processor architecture. Is it not compulsory? It is not compulsory to support all the operating systems by all processor architectures. So we can check it once. Either Core i3 processor, A15 chip, Qualcomm Snapdragon 695 processing element, TM4C123, GH6PM, whatever the processing element we are choosing in our embedded system, is it supported by the corresponding operating system or not? That is first functional requirement. Next, memory requirement. Whatever the operating system we are choosing here, that needs to be stored in the flash memory or secondary memory devices or non-volatile memory devices. At that time, that size of the OS matches our memory size. Suppose operating system size is 10 GB. But if a mobile memory for secondary memory device is only 12 GB or below 10 GB means it is not suitable. So check the memory requirements. What is the memory size required to store the real-time operating system? Either 10 GB means our secondary memory device storage may be more than 10 GB. Like that, either flash memory or whatever the type of memory, secondary memory we are using here. At the same time, while switch on the system, while utilizing the device, the OS is loading into the primary memory device. All services are loading into the primary memory, that is volatile memory or random access memory. That random access memory size is sufficient for operating our device by using the particular operating system. Is it sufficient or not? So finally, we need to check the memory size. Primary memory size is suitable for our design or operating system. Either 2 GB RAM, 8 GB RAM or 16 GB RAM or more than that one. Suppose if you want to play games, at that time we use another operating system. That OS is sufficient, suitable for our RAM. The RAM is sufficient or not? Neither. Next, real-time capabilities. Real-time means they have some deadlines. They have deadlines. Means within that time, the task must be completed. So, whatever the operating system we are using here, is it meet the deadlines or not? In this case, we need to check scheduling policies or scheduling algorithms which meets the deadline. In some of the cases, some of the services may be blocked while running the highest priority task. It takes some time. That is called some delay. Let us consider. The delay is reasonable or not. Okay. We need to check that interrupt latency should be minimal. Is it minimal or not? We need to check. That is kernel services. So that operating system kernel provide all the services or not. Primary memory management or memory management, process management, interrupt management, time management, or whatever the services we want. So if you look at the processor support, it is not necessary that all RTOS support all kinds of processor architectures. It is essential to ensure the processor supported by the real-time operating system. Next, memory requirements. So the RTOS requires ROM memory for holding the operating system files. It is normally stored in the non-volatile memory devices like flash memory. So it is also requires working memory while doing the operations. The services or apps, whatever the apps we are using, VLC app, or browsing Google Chrome app, or Gmail app, whatever the apps we are using in our embedded system, those apps are loading into the primary memory. So this memory size is sufficient or not under particular operating system. Next, real-time capabilities. It is not mandatory that operating system for all embedded system needs to be real-time. The embedded OS is real-time in behavior. Real-time means deadlines. So here, which scheduling algorithm we are choosing here? Priority based scheduling, shortest of first scheduling, or round robin scheduling, or first in first out scheduling, or last in first out scheduling, or preemptive scheduling or non-preemptive scheduling algorithms. Which scheduling algorithm is the best for particular design or particular requirement? Next, kernel and interrupt latency. The kernel of the operating system may disable interrupts while executing certain services, and it may lead to interrupt latency. So while doing some highest priority task, some of the services may be blocked. So interrupts will be disabled. Some of the highest priority task is running on. So whatever the time taken by highest priority, that time, execution time, during that time we are not executing other processes. Is it okay or not? For an embedded system whose response requirements are very high and this latency should be minimal. So the interrupt latency should be minimal. So waiting time or you can consider. Next, inter-process communication and task synchronization. So it depends on the operating system. Operating system contains kernel. Kernel is interacting with the actual hardware. So based on the type of operating system we are using here, based on that we can implement different types of inter-process communication methods and task synchronization techniques. Next, modularization support means dynamically we can modify the design or not operating system. Suppose sometimes the operating system may be updated to the 13 version to 14 version or 14 version to the 15 version. So our operating system is able to support that plugins or not. Or a new application needs to be installed in our design. Is it supporting or not? Because day by day requirements will be changes and new apps will be coming into the market. Like suppose I am working in JNT University. They require JNT biometric that contains some app. That app supporting by our Android operating system or not. Or some new application, new gaming application is entered into the market. That gaming application will be working in our operating system or not. Like that. So dynamically we can update the design operating system or not. Is it possible or not? So it is very useful if the operating system supports modularization, where in which the developer can choose the essential modules and recompile the operating system image for functioning. Next, support for networking and communications. Day by day, various new plug-in, plug-out devices are coming into the market. While interfacing with that plug-in devices, suppose new pen drive is new manufacturer enter into the market and they design some flash memory device or hard disk or any Bluetooth devices, whatever may be. So at that time, if I want to utilize that one new device, our operating system is supporting that new device or not, or our embedded system is able to interface with the device or not. Okay. The OS kernel may provide stack implementation and device driver support for a bunch of communication interfaces and networking. Ensure that the operating system under consideration provides support for all the interface required for embedded product. Next, development language. Suppose I want to design the new application in Java language. So is it possible to run that Java application in our operating system? Or framing networks, .NET framing works. Is it possible to run that .NET works or applications in our operating system? Is it support or not? Okay, we need to check new applications designed using Java language or web applications using .NET frameworks or any new languages. Suppose R programming language is coming into the market. Python is coming into the market. So different applications designed using different types of high level languages, either Python, either R script, RS language, whatever may be, whatever the new language is coming into the market. Our operating system is able to support that languages or not, like this. So the certain operating system include the runtime libraries required for running applications written in the language like Java, .NET, Python, C++, R script, like that. Is it able to support or not? The operating system may include these components as built-in component. If not, check availability of the same from the third party. So if it is not available, we are taking the support from the third party tools. So these are the various functional requirements we need to consider while choosing the real-time operating system. Next, we are going to check non-functional requirements. Those may be either we need to design ourselves or readily available in the market, or cost, tools, complexity in the design, supporting. So we can check one by one. First, custom developed or off-the-shelf components. If it is possible to go for the complete development of an operating system suiting the embedded system needs, or use the off-the-shelf or readily available operating system. So no need to design the operating system by ourselves. Those are readily available in the market. Example, suppose I want to design some new applications, smart home security. At that time, I no need to design the operating system by myself. Arduino boards are available in the market. The operating system also available in the market. I can use that Arduino boards and corresponding operating system, and I can design my desired requirement, either home automation, either agricultural requirements, either medical requirements, whatever may be. That is readily designed and available in the market. Either Arduino boards and Android operating system, or Raspberry Pi operating system, or Raspberry Pi boards, like that. So the decision on which to select purely dependent on the development cost and license fees, what are the things. Next, cost. So the total cost of the design, is it reasonable or suitable for the design? Suppose I want to design a FM, basic FM. If I use 1000 rupees or 2000 rupees for operating system or instructions, is it suitable? The customer is able to purchase that one with that cost? No. Basic FM cost is 100 rupees is available in the market. 100 rupees or 120, 200 rupees basic FM. But if I use 1000 rupees cost, invest on that one, it is not suitable. So we can check the cost for overall design development. So the total cost for developing or buying the operating system and maintaining it in terms of commercial product and custom build needs to be evaluated before taking a decision on the selection of OS. So finally, the cost is suitable or not, or reasonable or not. Shall we purchase the antivirus with more cost in our mobile phones or wherever? We can use whatever the inbuilt antivirus software is available in the mobile phone. We can use that one. In some cases only, we can purchase with some cost. Either 1000 rupees, 1 year validity AVG virus or Norton, McAfee. We can use that one by paying the amount with reasonable cost. We are not paying 1 lakh rupee or 2 lakhs rupees for providing 20,000 mobile phone security cost. Next, development and debugging tools availability. If you want to design the operating system, what are the tools required? Is it available in the market? Or is it reasonable cost? Or correspond how much time it will take? Development time, because day by day, within that time, a new products coming into the market. Initially, we are using, in 2008, we are using 2G mobile phone or 2G network by using the Symbian operating system or initial Android operating system. Later on, we are getting 3G, and in 2016 onwards, or something 15 or 14, Jio introduced 4G network. At that time, very few devices are supporting 4G network and corresponding operating systems also. Very few operating systems are available to support the 4G network. Again, we are getting 5G network within 2 years. Suppose development time takes 5 years or 6 years. What is the use? Suppose now 5G is going on. If you are designing 4G operating system or supporting operating system, is it required? Is it useful? No. So, how much time it will take to design a new operating system? For that, corresponding tools are available or not. Suppose if you want to design an operating system, we are learning every time languages, new languages. It takes some more time. That's why the manufacturer, the supplier, they are providing some of the tools for developing the operating system. So, those are available or not? Readily available. Are they reasonable cost available or not? If you want to purchase license, we need to pay some of the lakhs of amount. So, is it okay for designing? Is it reasonable? Like that, we need to check. Similarly, how much easily we can design at the same time, how much easily we can check the debugging. Debugging means functionality deviations will be checked here by setting the breakpoints within that time. Otherwise, in the olden days, they are checking the functionality behavior after executing each instruction. At that time, the code length is very few lines, the 10 lines or 20 lines or below 100 lines. But nowadays, the code length is more, lakhs of lines. If you are using a line by line execution response, means how much time it will take to find out the functionality deviations. So, by using debugging tool, wherever we can want to check the response, at that point, we can set the breakpoint and verify the functionality. So, the tools are available or not? Debugging tools. We need to check. So, the availability of development and debugging tools is a critical decision making factor in the selection of the OS of our embedded system design. Certain operating systems may be superior in performance, but the availability of the tools for supporting the development may be limited. So we can check what are the limitations and what are the cost and availability. Next, how much easily we can design the operating system. That is ease of use. How much easily we can design the real-time operating system which meets the deadlines or which meets the embedded system requirements. How much easily it is used as a commercial RTOS is another important feature that needs to be considered in the real-time operating system selection. Next, while using the device, while using the design, embedded system, if the operating system fails or if I found any bugs or software issues are there, we have to support the provider, supplier, providing the supporting or not. That is mostly important because if supporting is not available, most of the customers not prefer to purchase that devices. Okay. For a commercial embedded operating system after sales in the form of email or on-call services or some different applications for bug fixes, critical patch updates and support for production issues should be analyzed thoroughly. So the supplier able to clear the issues, whatever the issues we are getting while using the design or while using that operating system, either Android operating system issues or iOS issues or semi-annual issues or AC, whatever the devices we are using here. If any software issues are there, that manufacturer or provider supporting that or not. So like that, we need to consider functional requirements and non-functional requirements while choosing the real-time operating system. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.